Hello again, welcome back. Today, we're going to talk about prime numbers and prime factorization. So, as the title described, we are starting out with prime numbers and prime factorization. First of all, a prime number. That's going to be a number whose only factors are 1 and itself. Examples of this are going to be, for example, 2. You can only divide 2 by 1 and itself. 3, 5, 7, 11, 13, 17, 19, 23, and the list is going to go on. There's an infinite number of prime numbers, just like there's an infinite number of, well, just about any kind of number. The trick is that there isn't any real dead set pattern for prime numbers. They don't necessarily have to count 1 at a time, or 2 at a time, or 4 at a time. In fact, sometimes they go back and forth from counting 4 at a time, and suddenly to 2 at a time, and then back to 4 at a time. There's no real rhyme or reason. That's not the super important part. The thing you have to understand is that these prime numbers can only be divided by itself and 1. So, prime factorization is going to be the process of breaking down larger numbers into only prime factors. And don't worry, we'll be practicing this as well. We'll start by breaking down the number 12 into only its prime factorization. For starters, we're going to think about what numbers we can divide 12 by. We can divide 12, since it is an even number, by 2. So we'll write it out. 12 divided by 2, and that's going to give me 6. At this point, we have to decide anything that is a prime number we will put in a box. Anything that is not a prime number, we are going to circle. So, my prime number, we will put inside of a box. And anything that is not a prime number, we will continue to circle. At this point, we're going to continue. 6 can be divided, once again, by 2, which will give me an answer of 3. This time, however, both of my numbers are prime. So, we are going to put both of them into boxes. My final answer for this problem is then going to be everything inside those boxes in a multiplication problem. The easiest way to do that is just write it in the order it appears. We have 2 times 2 times 3. That's my answer. This is the prime factorization of 12. And you can check it by actually doing that multiplication. 2 times 2 will give me 4, times 3 will then give me 12. One other thing you should be doing, if you feel comfortable for it, or as a matter of fact by the end of the unit you will be comfortable with it, is you need to combine any of the multiplication parts into exponents. What I mean by that is count up how many 2's you have and combine them. In this case, we have 2 being multiplied 2 times, but we only have 1 3, so we'll leave that alone. This would be the better answer as opposed to this one. But we'll do a few more examples because I've got plenty of blank space all over this paper. The next number we'll try out is, how about 18? We'll write 18 here and circle it, and this will be my starting point. A number I could divide 18 by, I'm going to do something unconventional, and I will go with 3 this time. I'm not going to start off with 2, and that's okay. You do not have to start off by dividing by 2 if it's an even number. It just is a good, easy starting point. 18 divided by 3 is going to give me 6. I'm going to go ahead and circle that 6 as we can continue to divide it. I'm going to put this 3 inside of a box. That 6, much like the problem before it, can be divided by 2 to get 3. Put all of those in a box. I have only boxes left. I'm finished. All that remains is to put this in a nice, neat, and easy to read form. So we've got a 2 times a 3 times a 3. But I can make this a little bit neater. I can make that 2 times, and there are 2 3's, so I have 3, which is being multiplied 2 times. And I'll use this as my final answer. All right. How about a bigger one? Let's try a really properly large number, something crazy. Like, for example, 60, no, not 64. I pick on 64 a lot. Forget it. We'll pick on it a bit more. 64. 64. Quite a bit larger than 12 or 18, but the process is going to be the same. We can still divide 64 by 2 since it is an even number. And we'll go ahead and give that a try. 64 divided by 2 will give me 32. We'll go ahead and put that 2 in a box and circle my 32. As we can continue to divide it, it is still an even number. 32 divided by, once again, 2 will give me 16. I'll go ahead and circle my 16 and put the 2 into another box. We can, of course, continue to work on that 16, but I'm going to break it up into 2 4s this time because I don't feel like dividing by 2 again. And 16 divided by 4 will give me another 4. This is a square number after all. I'm then going to break up both of those 4s into a pair of 2's. 2, 2, 2, 2. And I'll take a shortcut by going ahead and drawing my boxes like that, because why not? We end up with not 1, not 2, but 1, 2, 3, 4, 5, 6 2's that make up 64. And it would be a little cumbersome to write out 2 6 times. That would look like this: 1, 2, 3, 4, 5, 6. That's a bit cumbersome. We can actually take this and we can make it a little bit easier to read by just saying that we are taking a 2 and multiplying it 6 times. Just like that. Quite a bit easier to read and quite a bit less to write. And this is all that goes in for prime numbers, numbers that can only be divided by 1 in themselves, and prime factorization, breaking down larger numbers into their prime number forms. And that's all there is to it. I hope this helped you. Thanks for watching.